Now the information given on the first problem actually tells you that you have 0.19 or 19% of the distribution between z equals 0 and z equals 0.5. And 34% between z equals 0 and z equals 1. 43% between z equals 0 and z equals 1.5. Not drawn very accurately, but and 48% between z equals 0 and z equals 2. This is the type of information that you get on a table of z values, and specifically on the table that you see in your text. And we'll talk about that table as soon as we get comfortable with this idea. Okay, and of course you have the 19, 34, 43, and 48% on the left at negative 0.5, negative 1, negative 1.5, and negative 2. Here we depict a normal curve, and the area between 0 and z is this region. Okay, so that if z was equal to 1, that area would correspond to this region. We would shade the region between z equals 0 and z equals 1 and indicate that that area is 34% or 0.34 of the total area under the curve. Here we depict the area between z1 and z2. Now the questions that you encounter ask you to find areas between two values of z. And we want to talk about first how you do that, and second how you do that with this type of information, the type that you're going to get on the z tables. Okay, now we want the percent of the area between z equals 1 and z equals negative 0.5, for example. Well, z equals 1 is here. Of course, here's 0, and here's negative 0.5. These are z values. Of course, we have negative 1, negative 2, and we have 2 out here. But we can label as much as we want to, but right now we want to just see where the area is, where the region is between z equals 1 and z equals negative 0.5. So, between 1 and negative 0.5, well, negative 0.5 is cut off here. So, that region is going to go from negative 0.5 to 1, and we'll shade it. It looks like this. Now, what's the area? What's the area of that region? Well, the area is (19%), which is what we have here, plus 34%, which is what we have here, which is 53% or 0.53. Because, as we know, 0.19 goes between 0 and 0.5, or between 0 and negative 0.5. So there's our 0.19, and here's our 0.34 between 0 and 1. Now, if we use this information, how do we calculate this? Well, from the middle to here is 0.19. From the middle to z equals 1 is 0.34. Okay, from here to here is 0.34. So we have the same information. So we have on this picture, we would be adding 0.19, the 0.34, which isn't written real well. And that's again 0.53. There's really very little difference between this information and this information. Now, if we wanted to get the region between, let's say, z equals 0.5 and z equals 2, well, we'd have to say, well, from z equals 0 to 0.5 is 0.19. Now, that's not included in the region between 0.5 and 2. But the region between 0 and 2 is 0.48. So what we can do is we can subtract the area between 0 and 2, and from that we can subtract the 0.19 that we're not including in the region between 0.5 and 2, and we would get 0.48 minus 0.19, which would be 0.29. We'll look at that a little further in a minute.